Hello, viewers. In today's session, we are going to discuss another important problem from definite integrals. And in this session, we are going to establish this important integral inequality using properties of definite integrals. So here we have to establish that the value of this integral, that is integral from pi by 4 to pi by 3 sine x dx, it lies between these two numbers, that is pi over 12 times square root of 2 and pi root 3 divided by 24, right? So let us see how easily we can establish this integral inequality using an important property of definite integrals. So let us first state the property. Suppose we have a function, say y is equal to f of x, which is a continuous function in the interval that is a comma b. And let us suppose that this function y is equal to f of x has a minimum value as small m. So small m denotes the minimum value of the function f of x in this closed interval, that is a comma b, and the capital M denotes the maximum value of this function in this interval, right? So here we have the property that is m times b minus a is less than or equal to the integral from a to b, and here we have f of x dx, and this integral is less than or equal to capital M times b minus a. So this is an important property of definite integral, which states that if we have a continuous function y is equal to f of x defined in some interval a comma b, and small m denotes the minimum value of f of x and capital M denotes the maximum value of f of x, then the value of this integral is greater than or equal to this product, that is m times b minus a, and this integral is less than or equal to this product, that is capital M times b minus a. So here we are going to utilize this property to establish this integral inequality. So let us first take the integral that is pi by 4 to pi by 3 sine x dx as I, right? So here we have this integral, and if we compare this integral with this one, that is from a to b f of x dx, then we can easily see that the limits, that is the lower limit a is pi by 4, the upper limit b is equal to pi by 3, and the function f of x is the sine function, which is a continuous function in the interval that is pi by 4 to pi by 3, right? And moreover, here we can easily see that this function sine of x is an increasing function in this interval, because if we find the derivative, that is f prime of x, then here we have the derivative of sine x is cosine x, and this derivative f prime of x is greater than 0 for all values of x belonging to this interval, that is pi by 4 to pi by 3. So now let us find out the value of small m. So small m is the minimum value of f of x, and f of x is sine x. So here at this point, that is pi by 4, we have the minimum value of this function sine of x, right? We are here confining ourselves to only this interval, right? So the minimum value of sine x, it occurs at this point, that is x is equal to pi by 4. So here we have sine pi by 4. So this is 1 over square root of 2, and the value of capital M is the maximum value of f of x. So here the value of capital M can be obtained by taking x is equal to pi by 3 in the function f of x. So here we have sine pi by 3, and this is sine 60 degrees, and sine 60 degrees is equal to square root of 3 over 2. So now let us substitute these values in this inequality. So here we have small m times b minus a. So small m is 1 over square root of 2, and b minus a is given by pi by 3 minus pi by 4, and then we have less than or equal to. Then we have the integral from a to b. So here we have pi by 4 to pi by 3, and here we have sine x dx, that is less than or equal to capital M times b minus a. Capital M is square root of 3 over 2, and here we have pi by 3 minus pi by 4, right? So the difference pi by 3 minus pi by 4 is given by here we can take the LCM, that is 12. Then we have 4 pi minus 3 pi, that is pi over 12. So substituting the value of pi by 3 minus pi by 4 as pi over 12, now this inequality can be written as 1 over square root of 2 times pi over 12, and then we have the integral pi by 4 to pi by 3 sine x dx, and here we have square root of 3 over 2 times pi over 12, right? So solving these two terms, we can now write pi over 12 root 2, and here we have the integral pi by 4 to pi by 3. This is sine x dx, and here we have pi root 3 over 12 times 2 is 24, and this is our required inequality which was to be established. So viewers, this is how by using this important property of definite integrals, we can easily establish these kind of inequalities.